to talk about the Pythagorean theorem. This will start our unit on trigonometry. Trigonometry basically is just finding angles and side measures of triangles. So that's what trigonometry basically is finding missing angles and sides of triangles. And we're going to start trigonometry by talking about the Pythagorean theorem. Now, people think that the Pythagorean theorem only says a squared plus b squared equals c squared. Well, the Pythagorean theorem is an actual theorem, and it states that if you have a right triangle, then the sum of the squares of the lengths of the legs of the right triangle is equal to the square of the hypotenuse of that right triangle. That's what it says. The sum of the squares of the lengths of the legs in a right triangle is equal to the square of the hypotenuse. We abbreviate that to a squared plus b squared equals c squared. Okay? But it's really talking about squaring the legs and adding those together equals the square of the hypotenuse. All right? So yes, we do abbreviate it to a squared plus b squared equals c squared. But that's not what the Pythagorean theorem actually says. Okay. Amanda has lost her notes. I only have 50,000 things on my desk. I found it. Okay, so let's just fill in. I didn't really need them, but just for fun. So the Pythagorean theorem is used to find the missing sides of a right triangle. It has to be a right triangle or the Pythagorean theorem is not working. Sorry, neither is my screen. All right? It has to be a right triangle, so we need to look for that little right angle box in a triangle before we can use the Pythagorean theorem. Sides A and B are called the what? Legs of the right triangle. They are forming the 90-degree angle. So the two sides that touch and form the 90-degree angle are called the legs. The C side is across from the 90-degree angle, and that is called the hypotenuse. My pen is not writing. Hello, pen. There you are. Technology is not my friend today. Hypotenuse. So the longest side of a right triangle is the hypotenuse. And for any right triangle, we can say the sum of the squares of the lengths of the legs equals the square of the hypotenuse, abbreviated as a squared plus b squared equals c squared. All right, so I'm going to insult your intelligence for a few minutes. Number one, find the value of x. Round your answer to the nearest tenth. That means we're going to get some decimals. All right, so is x leg or hypotenuse? Hypotenuse. So when I plug into a squared plus b squared equals c squared, it goes in for which one? C, right? So I'm going to plug in 8 and 13 for A and B. It does not matter which order you do them in, because A and B are just going to be added together after I square them. And I'm just going to call C x squared. All right. Do y'all know how to do a square in your calculator? The x squared button is diagonal from the 7 key. So 8 squared is what? 64. Plus what's 13 squared? Equals x squared. Then what do you do to solve for x? Add 64 plus 169. What do you get? 233 equals x squared. Am I finished? No. How do we get the x completely by itself? You get rid of a square. You take the square root of both sides. All right. So I need a calculator. Give me a second, y'all. Sorry. My calculator's not wanting to come on today. All right. Just to show you how to take a square root in case you have forgotten. To get a square root symbol, you're going to hit the second button and the x squared button. That's the same as the x squared. Yeah, the diagonal from the 7. See, it has a little blue square root sign in it. So hit second and then square root 233. And it says round to the nearest tenth, so that's going to be about 15.3. Y'all agree? Okay, so I'm going to put squiggles because it's not exact. So I'm going to say 15.3 is approximately x. So anytime I round, I put squiggles. Now, let's see if that answer makes sense. We're finding the hypotenuse, and we know the hypotenuse is always the largest side of a right triangle, isn't it? Is that number going to be my largest side? Yes. Okay, so that's one kind of way to see if your answer makes sense. Make sure the hypotenuse is always the largest side. Number 2. Are we finding a leg or a hypotenuse? This time we're finding a hypotenuse again. So 27 and 22 are my legs. So put them in for A and B. And X is the hypotenuse. Then our calculator can help us. What's 22 squared? 22 squared is? Y'all did 27 first. Yeah, 484. Don't matter the order for A and B. And then 27 squared is 729, right? And that equals X squared. Then I add those. 484 plus 729. What do we get for that? Equals X squared. And how do we get just X? Second X squared or second square root. 12, 13. And it says round to the nearest tenth, which is 1 decimal place. So X is approximately what? 34.8 units. And that's the hypotenuse. Is that the largest side we got? Yes. So always make sure your hypotenuse is the largest. On number 3, what are we looking for on number 3? A leg or a hypotenuse? A leg. 9 is the hypotenuse. Okay? So it doesn't matter if you put X in for A or B. Just make sure it's one of those. Okay? I'm going to do it for B just for the heck of it. So I'm going to say 7 squared plus X squared equals my hypotenuse is 9. So 9 squared. All right, now I'm going to do my squares. What's 7 squared? 49 plus X squared equals what's 9 squared? 81. And then I'm subtracting 49 on both sides to get X by itself. What's 81 minus 49? 32. Oops. And then how do I get just X? Square root should be 5 point something. Approximately 5.7. Everybody getting that? Anybody having trouble typing square roots into their calculator? All right. And 9 should be the hypotenuse. Is it still the longest side? Yeah. All right. Can we skip number 4? It's kind of the same thing. Yeah. Number 4, you're looking for a what? A leg, right? So you put it in for A or B. Very good. Look at number 5. Number 5. What kind of triangle is this on number 5? Well, there's actually 3 triangles, but the outside triangle is isosceles, isn't it? Now, okay, we just learned a theorem about triangles that said if we have a line perpendicular and they are the same distance from this point, we know they were because it said those were congruent, then it's on the perpendicular what of that segment? Bisector. So that means I can split this length of 22 into 11 and 11, correct? And that's just using what we just talked about yesterday. So this is 11 and this is 11. So that way I can basically just use one triangle to find one of the little triangles to find X. Does that make sense? Does that make sense? So is X, so I'm just going to ignore this triangle over here. So you just ignore one of them. So now I just have a little right triangle. Is X a leg or a hypotenuse? It's touching the 90-degree angle, so it's a leg. Okay, so if I want to find X, I treat it like a leg, so I'm going to put it in for A this time. So X squared plus 11 squared equals 24 squared. So is everybody okay with what I've done so far? Yeah, that converse theorem yesterday told me that we had a perpendicular bisector there. So x squared plus 11 squared is what? 121 equals, what's 24 squared? 576. So we want to get x by itself. So how do we do that? Yep, subtract 121 on both sides. So x squared equals 455. And take the square root. Round it to one decimal place. X is approximately what? About 21.3. And that is smaller than the hypotenuse, isn't it? Good job. All right. Look at number 6. That is some kind of quadrilateral, isn't it? So you might be thinking, how could we use the Pythagorean theorem here to help us find x? What do y'all think? What could we do to find x? Why would we do that? Okay, I need a right triangle somewhere, right? How can I make a right triangle here?
Cut it from that top right angle.
Oh, so I can make a rectangle here, right? So you're right. So, because if this is a rectangle, so these are all 90-degree angles, right? So if this length is x, then this length is x, right? And this length is 5. And so he was right. What's the length of this leg down here, or up here on the top? 18 minus 5 is what? 13. Now do I have enough information to find x? Yeah, I have the other leg and the hypotenuse. Y'all see that? So sometimes you have to chop some of your shapes up in different ways to get it to where you see a right triangle. Does that make sense? So x is a leg. So x squared plus 13 squared equals 16 squared. So x squared plus 169 equals 256. Subtract 169 on both sides. What do we get when we subtract those? Yeah, x squared is 87, so it should be approximately 9 point something. About 9.3. And make sure the hypotenuse is longer and 16 is longer than 9.3. Y'all see how we did that? So yeah, I just made a rectangle right here, and since they told me this length, I knew that was the same, and whatever's left over to make it the 18th is what I needed for that other leg. Good job. Let's look at number 7. Bum, bum, bum. Okay, so I've got this big old triangle. Is that big triangle a right triangle though? No, but I have 2 little triangles right here that are right triangles, aren't they? Right? So if I could use those little right triangles and find this leg and this leg, then I can add those together and get x, couldn't I? Y'all see that? Because they're both legs because they touch the right angle. So that means 14 is a hypotenuse to the left-hand side triangle, and 29 is a hypotenuse to the right-hand side triangle. Y'all see that? So after I find these 2 little legs, I can put them together to get x. Does that make sense? Okay, so let's find A first. Let's find A first. So A squared plus, what's the leg? I'm stuttering, y'all. What is the leg in the left triangle? The other leg. 12. Good. Equals 14 squared. So A squared plus 144 equals what? 196.
Subtract 144. What's 196 minus 144? 52. Take the square root. Should be approximately 7 point something. About 7.2. So there's A. I'll use that in a minute. Any questions about how we got A? All right, now I want to find B. So I'm going to use 12 squared plus B squared. Now you could have put the B anywhere. It's just a random. You could have made up different variables if you wanted to. Equals 29 squared. Just know it's a leg. 29 is a hypotenuse. So 144 plus B squared equals, what's 29 squared? 841. Now what do I need to do to solve for B? So B squared is approximately, nope, sorry, I'm not ready yet. B squared is 841 minus 144. 697. And then square root. And round it to one decimal place, about 26.4. All right, and so X is going to be, I'm going to say approximately because I've rounded these answers, 7.2 plus 26.4, which is going to be approximately, what, 33.6? 33.6. Is everybody okay with that? I had to find two legs of two different right triangles, and then that put together to make that length of that big side of that triangle. All right. Well, looky. Here's another one that's kind of similar. Number 8. What do you think we're going to have to do to get X here? I got how many right triangles? 2. So if I just look at this top right triangle where X is, do I have enough information to find X? No, I don't have this other leg, do I? No. Is there a way I can get this other leg? Yes, by using Pythagorean theorem with the bottom triangle. Now for this side, is it a leg or a hypotenuse to the bottom triangle? It's a leg again, isn't it? So you got to look and see if it's a leg for each triangle, or you might have a hypotenuse in one and a leg for another. Does that make sense? So I'm going to call this another variable. I'm going to call that y. So I'm going to have to find y before I can get x. Y'all with me? So we just said y is a leg. So for the bottom triangle, y squared plus what's the other leg in the bottom triangle? 10 squared equals 25 squared. What's y squared? Oh, we don't know y squared. What's 10 squared? 100 equals what's 25 squared? And I subtract 100. So y squared equals 525, right? And then I take square roots. So y is approximately 22.9. Very good. So I can fill this in here, 22.9. So now, how can we get x? The Pythagorean theorem again, and x is the leg, isn't it? And 22.9 is a leg, and 28 is the hypotenuse. Very good. So I'm going to say x squared plus 22.9 squared equals 28 squared. Calculator will help me. 22.9 squared is about, I'll just go ahead and type it all in, 524.41. The less rounding, the more accurate. So I just like to wait and round to the end if I can. And then 28 squared is 784. So I subtract that. on both sides. So 784 minus 524.41. I'm getting x squared equals what?
259.5.
And then I take the square roots. I'm getting about 16.1. Are y'all? X is approximately 16.1. And that's what I was trying to find. And it is a leg, so it should be smaller than 28, and it is. Okay. Everybody okay with that? Okay, let's look at number 9. What did they just show us on number 9? Okay. I might not work the whole thing, but y'all can help me set it up. Just for sake of time, because we got some word problems to look at that are kind of challenging. All right. So we got to find x, which is a leg of this right triangle, and it's also part of a rectangle. Do you see that? So what kind of info? Oh, I could also use 20 over there because it says those are congruent, right? Right. So what other information do you think we could do here?
Figure out the other legs.
The little legs? How can I figure out the little leg? Yep, and then divide it by 2, right? Okay. So, because this side right here is 26, so whatever's left over will have to be added together right here. So what is 40 minus 26? 40, ooh, my handwriting. 40 minus 26 is 14, and then divide it by 2 and get 7 on each side, right? And then you would set it up x squared plus 7 squared equals 20 squared. So I'm not going to finish that, but is everybody okay with that? Y'all see how we did that? So sometimes you just kind of have to break up pieces and do a little at a time to eventually get there. I think that one is a little easier than the last one, honestly, because you still only have to do Pythagorean theorem once. Very good. All right, let's start seeing some word problems. Now, do you see on these word problems? I'm trying to put the whole thing on there. There you go. On these word problems, they didn't draw the triangle, right? There's no triangle. But if we're doing Pythagorean theorem, we need to see a right triangle, right? So guess what we're going to have to do? Get creative. Guess what Miss Isabel's not good at? Being creative and drawing pictures. But I'm going to try, okay? If you laugh at me, you will fail this test. Just kidding. A roofer leaned a 16-foot ladder against a house. Okay, I got a house. Here's my house. Here's my house. There's my house. Okay? He leaned a 16-foot ladder against the house. So what is it looking like that ladder is going to be? A hypotenuse, right? Right? If the base of the ladder, well, that would be the base. I love my horse. I guess my house is at the bottom of a hill or something. All right, so the base of your ladder is right here. It's 5 feet from the house. So what's this leg right here? It's going to be 5. So you're drawing and labeling 5 feet. How high up the house does the ladder reach? So we're looking for this height, how far it's going up the side of the house. Does that make sense? So do y'all see how I kind of drew that picture there? Okay. Drawing pictures help. So is my height that I'm looking for going to be a leg or a hypotenuse? It's a leg, because we already said this. The ladder leaning against the house is the hypotenuse, right? Hopefully our house is perpendicular to the ground. So that should make our right angle, right? So x squared plus 5 squared equals 16 squared. What's 5 squared? What's 16 squared? And then subtract 25 on both sides. You get 231. Square root.
What's the square root of 231? So x is approximately 15.2 feet up the house, right? So word problems need words with their answer. They especially need units, okay? Especially need units. So drawing the picture absolutely helps. Even if your picture is crappy and looks like a 5-year-old drew it, like mine does, okay? They really help a lot. Okay, y'all ready for number 11? All right. Kurt is building a rectangular deck. Okay, that means I need to draw what shape? A rectangle. Okay. If the dimensions of the deck are 10 feet by 23 feet, that means the length or the width is 10 feet and the other one is 23 feet. So I guess I'm going to make my 10 feet my shorter side, right? Yeah. Just to make it somewhat by scale. What is the length of the diagonal of the deck? What does it mean by diagonal? From one corner to the opposite corner, right? And these are rectangles, so rectangles have 90-degree angles. So if I'm looking for the length of a diagonal, I'm looking for what of a right triangle? Hypotenuse. Yes, a diagonal of a rectangle will always be the hypotenuse. Y'all with me? So it should be longer than 23 feet, right? So 10 squared plus 23 squared equals x squared. 10 squared is 100 plus 23 squared is 529 equals x squared. 100 plus 529 is 629. And then I take a square root. What y'all get for the square root of 629? About what? 5.1-ish. So about 25.5.1 what? Feet for the diagonal. And that is longer than 23, isn't it? Not terrible, is it? Okay. Ashley jogged 3.4 miles east and then 5.7 miles south. So here's Ashley. Hey, Ashley. She's got her tennis shoes on. She's got her ponytail going. She's a runner. She's got bangs too, because we don't want her bald. There's Ashley. Okay? I guess she needs a face. Go away. She's smiling. Woohoo. Run, run. Fast as you can. Can't chance me. I'm Ashley. Okay. She jogged 3.4 miles east. Choop. 3.4 miles. And then she jogged 5.7 miles south. I'm trying to draw a perpendicular line. 5.7. Y'all with me? How far is Ashley from her starting point? Well, the shortest distance between 2 points is a straight line. Y'all ever heard that before? So it's talking about exactly, here she started, down there is where she ended, exactly, without cutting corners and without following the road. If she's just throwing a rock, how far would she have to throw it to get to where she started? So I'm looking for a what? A leg or a hypotenuse? A hypotenuse. So 3.4 squared plus 5.7 squared equals x squared. Calculator, help me. 3.4 squared is 11.56 plus 5.7 squared is x squared. Add this together. And I'm getting 44.05. Did y'all get that? And then square root. How far is she? About 6.6 miles from where she started. That's if she runs through the woods, right? All right. Y'all try to draw this picture on your own. And then go ahead and try to solve it. Try to draw it and solve it on your own. That's what you're going to have to do on practice anyway. So I need to see a right triangle somewhere on your paper.
Right here, you could have gotten an axis of symmetry of x equals 3, a vertex of 3, 2, filled in your table. So 1, 6, 2, 3, 3, 2, 4, 3, 5, 6. And the graph should look like what's on the screen. So maybe all real numbers and radius y is greater than or equal to 2. Raise your hand if you got that correct. Very good. Raise your hand if you're on the right track and give me more time.
Y'all tell me, which one is the hypotenuse? The wire or the pole? Wire. Is there a clue? It's longer, right? So if you're not sure if the wire or the pole is the hypotenuse is going to be longer than the leg, right? And I'm hoping that my pole is perpendicular with the ground. Okay? If not, they're going to have to fix that. So I'm saying 31 is my hypotenuse and 25 is the height of the pole. Are y'all okay with that? Okay. So I'm looking for how far from the base of the pole, which is right here, does the wire meet the ground, which would be right here. So I'm looking for this length. Y'all agree?
Yes.
Which is a leg, right? So x squared plus 25 squared equals 31 squared. So x squared plus 625 equals, I don't know what 31 squared is. What'd y'all get? 961? And you subtract 961 minus 625, and you get 336, right? And then you take the square root, and y'all get approximately 18.3 feet. Raise your hand if you got that the distance is approximately 18.3 feet. Show my square rooting. Good job. All right, turn to page 3 in your notes. This won't take long, I promise. So the Pythagorean theorem has a converse, just like a lot of theorems do. So I told you earlier that the Pythagorean theorem says if you have a right triangle, then the sum of the squares of the lengths of the legs equals the square of the hypotenuse, right? Well, y'all know a converse theorem reverses the order, correct? So the converse theorem to the Pythagorean theorem says if you have a triangle such that the sum of the squares of the length of the legs equals the square of the hypotenuse, then the triangle is a right triangle. Okay? So Pythagorean theorem says if it's a right triangle, then a squared plus b squared equals c squared. The converse says if a squared plus b squared equals c squared, then you have a right triangle. You see the difference?
Okay, so when you're doing the converse, you're proving that you have a right triangle. Okay, so if c squared equals a squared plus b squared, then you have a right triangle. Now C is going to be your longest side. Okay, C is the longest side, whether it's a triangle, a right triangle, or not a triangle. Okay, or not a right triangle. If C squared is larger than the squares of the two smaller sides added together, then you're going to have an obtuse triangle. If c squared is larger than a squared plus b squared, it's an obtuse triangle. So if c squared is smaller than a squared plus b squared, what kind of triangle do you think you're going to have? An acute triangle, when all of your angles are less than 90. So what you're going to do is you're going to take the longest side and square it, take the smaller sides, square them, add them together. If the longest side squared is bigger than the two smaller sides squared, added together, then you have an obtuse triangle. If it's smaller than it, you have an acute triangle. If it's exactly the same amount, it's a right triangle. Okay? Now, you see that's highlighted right here? When you're checking to see what kind of triangle you have, you always want C on the left. All right? If you're checking to see what kind of triangle it is, you always want to do C first. Okay? All right. First, we have to determine if it's even a triangle at all. Okay? So first you got to see if it's a triangle at all. It's a triangle if, y'all, the two shorter sides added together is bigger than the third side. So what's 3 plus 7? Is 10 bigger than 9? Yes, so this one does make a triangle. If not, your sides don't match up and make a triangle, right? So this one is a triangle. So not a triangle is going to be an option. So that's how you check that. You add the two smaller ones. If that's bigger than the largest side, then it is a triangle. Now we have to check for what kind of triangle it is. So what is the largest side? 9. So I'm going to say 9 squared. I'm going to put a blank there because I don't know what symbol goes there. 3 squared plus 7. So what's 9 squared? 81. What's 3 squared? 9 plus 7 squared. 49. What's 9 plus 49? So 81, compare it to 58. What symbol goes there? Greater than. So this is what kind of triangle? Obtuse. Okay, so you check the longest side squared and see how it compares to that sum of the smaller sides squared. Okay. So number 2. First, I'm going to see if it's even a triangle. Add the two smaller sides. Now, they might always be in order like this. Smallest to biggest, but they might not always be in order. So you're going to have to check. Is 20 plus 21 greater than 29? Yes, so this does make a triangle. So it's not a triangle. So how do we check? Which one's the longest side? So I'm going to check to see if 29 squared, how it compares to 20 squared plus 21 squared. So what is 29 squared? 841. And then 20 squared is 400, I believe. Plus 21 squared is something bigger than that. 441. So 841, compare it to, add those together, I get what? 841. So they are what to each other? Equal, which makes it a right triangle. Y'all see how we're doing that? Does that make sense? Let's do number 3. First, we have to check to see if it's even a triangle at all. So add the two smaller sides. What's 4 plus 11? Is 15 greater than 16? No. So this one is not a triangle. 15 is not greater than 16. Got it? Okay. Number 4, does it make a triangle? 17 plus 17 is bigger than 22. So it is a triangle. So how do we check to see which one it is?
22.
Squared, compare it to 17 squared plus 17 squared. What's 22 squared? 484. Compare that to 17 squared is 289. Plus 289. Add those together. I'm getting 578. Are y'all? So what symbol goes here? Less than. So this is what kind of triangle? A cube. Y'all see how that goes, or y'all need to see another example? So any question about those? All right. So we'll call this the end of notes for today. Have fun on your practice.